Now in the last video we were discussing about this problem which was about finding the number which is having odd occurrence inside this array, and then we discussed about the first algorithm that we have written here, which is by using the loops. So this is the first loop and this is the second loop, and by using these two loops the time complexity that we were taking was order of n square and the space complexity that we were taking was order of 1. But the problem is we have to solve this problem in order of n, not in order of n square, and that is because we are using two loops. That is why we are having order of n square as a time complexity. So let us introduce you with the second solution of the same problem, and the second solution is by using the hash tables, or you can say the hash maps. Let us read out what is the second solution. It says use the array elements as key and their counts as value, create an empty hash table, and one by one traverse the given array elements and store the count inside the hash table. What does that mean? Let us say that we have this array which is having the values 2 1 4 2 1 4 1 4 2. This is having one more element, assume, which is 1. Index locations are 0 1 2 3 4 5 6 7 8 and 9. And just for a bigger array, let me take few more values: 2 9 6 9 6. So this is 10 11 12 13 and 14. So in total we have 15 elements here. Now for this particular array, we know, for our purpose and for our understanding purposes, we know what is the number of 2. So it is 1 2 3 4. 2 is appearing even number of times. 1 2 3 4. 1 is appearing even number of times. 1 2 3. So 4 is appearing odd number of times and rest is even number of times. That's fine. Now what we are going to do is we'll take a hash table, or you can say a hash map, but this hash map will be again having two values. Number one is the key and second one will be the occurrence of that particular key. So we have numbers between 0 to 9, so it is 0 1 2 3 4 5 6 7 8 and total 9. So we have a total of 9 numbers. Again in the hash table we are going to use the formula, the most basic formula that is used in the hash table to map the keys is a key mod n, where key is the number, for example this number, and mod n is the size of the hash table, and in this case I'm assuming n is the range of the numbers. That means the numbers are between 0 to 9 only. Now we'll take every number one by one and we'll insert that number inside the hash table. For this we only have to go to the array linearly. For example, the first number is 2, so I'm going to do 2 mod 10, which gives us the value 2. So I'm going to store 2 here and the occurrence is 1. So next time if we encounter 2, then I'm going to just store the occurrence as 2. Again go to the next number 1 and I'm going to do 1 mod 10. That is, we just apply this hash formula on that number. You get the location and resolve the occurrence. Go to the number 4, it will be stored here and the occurrence is 1. Go to the number 2, it will be stored here but it has already occurred, therefore we are going to increment the value as 2. Go to the number 1, so I'm going to increment the value as 2. Going to the number 4, so I'm going to increment the value as 2. Going to the number 1, so I'm going to increment the value as 3. Again we have number 4, therefore increment the value as 3. We have number 2, increment the value as 3. We have again number 1, increment the value as 4. The number 2, increment the value as 4. Number 9, so it will be stored here, the value is 1. Number 6, it will be stored here, the value is 1. Number 9, it will be stored here, the value is now 2. Number 6, the value is now 2. After going through the entire array from the beginning, at the end I'm just going to check out this hash table and obviously I'm going to traverse the hash table from the beginning to the end. That means from the first number to the last number. I'm going to traverse the hash table to see in occurrence part am I getting any number which is having odd number. So I'm going to get that 3, this is an odd number, hence the number 4 that is represented by this number 4 is appearing odd number of times. This is how you can easily map all these numbers inside the hash table. Okay, and again this is a very easy strategy. The only thing is that you have to use a hash table, which is a little bit tricky to implement in case of C language. But if you see the languages like Java, the hash table is already implemented in Java. Inbuilt functions, or you can say methods, are available in Java for implementing the hash table. Now for going to this entire array, it will take order of n time to insert the values inside the hash table, and then going to the hash table from the beginning to the end, again it's going to take order of n time. I'm just assuming that we have a total of n numbers. Let us say the numbers are in range from 1 to k. We can, for simplicity purposes, we can implement a hash table which is having k index locations. Okay, but again it totally depends on your implementation, how you want to implement. You can, instead of implementing k, you can implement n, and the hash table itself will take care of the repeated values in itself, all these things that we will see in the upcoming video, where we are going to write programs to implement these programs in a hash table. Okay, so for now let us move on to the third solution, which is again a very interesting solution by using the XOR, bitwise XOR for that. But the reason why we are taking the third solution is because the time complexity that is taken by this hash table is order of n, because order of n and order of n, and the space complexity that will be taken by this will be order of n, because the hash table is again taking order of n space. Okay, if you have any confusion why I'm taking order of n, you can just let me know. You can comment over this video, I'll tell you why I'm taking order of n, but I'm just assuming that numbers are between the range of 1 to n, or you can say 0 to n, and there's a total of n numbers. Okay, now in the next video we'll see how to solve the same problem with XOR, and this will be a bitwise XOR, and then we'll also see the program implementations of all these 3 functions, all these 3 types that we have done in this video. Okay, let us move on to the next video here.